various tools. And these are very kind of vague. For example, in the incident response model, how is the verification phase different from investigation? In the verification, we were looking for basic evidence of the incident occurred before we started the full investigation. Well, how's it different from investigation? I mean, in both cases, we're searching for evidence, and we're trying to find proper ways of finding it and recovering it. So, it seems, though, in scope, the verification is a smaller scale or smaller scope subset of the investigation phase. In the crime scene model that we had, how is survey different from searching? Again, same principles here, that we're searching for different things, different scale, different scope, different purposes, but it's the same basic concepts here. And the end problem is that the process models are relatively arbitrary. It's not mentioned here, but the Digital Forensics Research Workshop actually had a focus last year on frameworks and process models. And there were 4 of us that presented various forms of these. And it was amazing to find out how many different phases people would have. Some had 17, some had 5, some had 2, some had 3. These are all fairly arbitrary. I approach it with a 10 phase. Some could be 4 phases. It all depends on the granularity you want to define for each phase. So, for example, in the incident response model we have, does the investigation phase, is it the same thing as both the analysis and examination phase of the Department of Justice model? Are they different? Are they the same? Or is the data analysis different from the crime scene event reconstruction? These are all kind of arbitrary containers we've assigned to these things without having any kind of underlying theory about what the minimum requirements are. So, maybe asking, well, is this just kind of an academic exercise of trying to define general theory for the sake of doing academic work? And it's actually really not. Because if you look at the Daubert Guidelines for entering technical evidence into a US court, there's a few guidelines you have to meet. One is, has the procedure been published and generally accepted in journals, especially, not necessarily conferences, but journals, has been published and accepted by the community that was used to get this evidence. And the second major category is, has it been tested by various experts, and what is the error rate, and is there a known error rate for this process? And these guidelines basically haven't been met at all, or haven't been strongly met for digital evidence. And there hasn't been many challenges in the courts to the evidence to actually force these guidelines to be met. So the current state, for publishing procedures, they basically have none of them have been published. They're all basically closed tools, and it's an intellectual property concern where they don't want to say how they're doing stuff because it could potentially ruin their market share. The closest thing are open source tools, but even they don't publish them in a documented format. You can read the source code to find out what they're doing, but there's still no detailed procedure of what they're actually doing. So so far, there's no procedure at all, basically, that's been published on this actual process. For testing and error rates, there's been basic testing that's occurred by NIST, the National Institute of Standards and Technology. And actually, Jim Lyle was here last year talking about this. And they basically, have done disk acquisition tools, which is basically, imaging the system before of, copying the system to files. They've done software write blockers, which are these tools you install in your systems that you don't write to a disk when you're examining it. So these are all very basic techniques. And there's been no formal testing of file systems at all. The closest thing are some images I have up on a SourceForge site on the digital forensics tools testing. And they're basically very small file system images that will test a certain thing like keyword searching or file recovery, et cetera. But they're fairly informal. They're not nearly as formal and rigorous as what NIST normally does for testing. So in general, there's still no even error rates from a formal analysis procedure for the area. So this is kind of what the motivation for this work was, to define requirements and procedures so that we can actually start moving ahead with these and start defining these guidelines. So the proposed solution is basically to define technical areas that are involved in this process, based on how evidence is created. And the issue is this may not resemble an actual process model. This could just be, general areas, but we can actually then map them into the actual process model. And then we have to define requirements based on each area, so we can actually start working on the guidelines. So definitions here before we get so basic definitions here. So an object in this case is basically some kind of collection of digital data. This could be a byte, it could be a sector, it could be a file, it could be a chunk of process memory, it could be any basically finite, bounded collection of data. We have a state, which is the value of an object's characteristics. So one way to think about this is like a data structure, all its different values. Those are its characteristics. or we can say it's the value in general. So the state of a file could be its content, value, memory example. Any kind of object, its value is basically its state. So we have some kind of event, which is basically an occurrence that changes the state of one or more objects. So we have some event that occurs, and we have an object that has a new value in it now. So a cause is basically an object whose state was used in the event. So an executable or a process is used to actually cause an event to occur. And we have an effect who are the objects that were changed by this actual event. So here's our basic schematic, visual process here. And this is a very high level right now. But our cause, we have this notepad process that's running in memory. It's going away. We have our operating system that's also running in memory. This is a buffer in the notepad process. And we want to save our buffer, what we're typing into a file. So this basic, very high-level event is basically the effect of this event is that we have the notepad process, which is in a new state. It's changed, its instruction pointer, various other things, to some other state in its code. So it's in a new state. We have this new file, 1.txt file. It's been created on the disk to represent this new file. So it didn't exist before, and it's a new object in the system. And we have our operating system that's now, there's a file descriptor or some other data structure in the operating system that's now changed state because of this event. So when we look at what evidence is. And basically an incident or a crime is basically that an event that violates a policy or a law in the system. And basically, so we have this event back here. Let's say this is actually, some illegal file. This may be the illegal event that was created when we save this file to our desktop or our system. That this is our event that we're investigating. So basically, we're trying to investigate these types of events. And the concept here is that there's only evidence of the event if the effect still exists. If we go back here, if this file object, these two are memory. Network processors and the operating system are memory. So when the computer turns off, these are gone. So when we go investigate the system later on, we may find this file 1.txt file on the actual hard disk. But if it doesn't, it's not there, then we have no evidence that this event ever existed. And we don't know that we can hypothesize that it occurred. We actually have no evidence that it actually occurred at all in the system. So the point is we have to find these effect objects to actually say whether the event occurred or not. So basically our digital evidence is basically some object that contains reliable information that supports or refutes some hypothesis. So if our hypothesis was, that this, notepad process was used to save this file, we have to find this information as actual evidence that this event actually occurred. And if we can't find it, we have to be able to explain why we didn't find it and what certainty we think it occurred. So this is basically broken up into 3 different phases now then, with this in mind, this notion of the events in mind. And the basic goal now of our investigation is to determine the events that occurred by recognizing digital evidence in the system. So there's 3 actually types, and this actually is very similar to our crime scene investigation approach, but with a few missing phases. So the first phase is preservation. Second one is actually evidence searching. And the third one is reconstruction. So preservation. The goal of this process is basically to preserve the state of as many objects as possible and document the crime scene. Again, the point here is if we don't have that effect object, then we don't know what occurred. So if that effect object is ever changed by other processing, we could have lost the evidence of the incident, of the event. So we want to preserve that state as much as possible in the system. So the common methods for doing this are basically shut the system down and make a copy of it. We saw that in the examples we did in the scenarios. Another example, if we can't take it down because it's too critical for some reason, we can unplug it from the network so the attackers still can't access the system and cause more damage. If we can't unplug it, maybe it's a really very critical web server, at Google or some other critical place that can't turn it down. We can look for suspicious processes and just kill them off or suspend them or isolate the ones that we think are suspicious in the area. Or we can do nothing, which isn't very effective, but it's still a legit response to actually just let things go and